Combustion forces on the piston rotate the crankshaft. The flywheel and pressure plate are bolted to the crankshaft. The clutch disc is sandwiched between the pressure plate and the flywheel. The disc is splined to the transmission input shaft, which in turn transfers power through the transmission to the differential and the drive wheels. The flywheel and engine power is to the left. That's the blue one is the flywheel. The transmission is to the right. That's the gray transmission input shaft. The green pressure plate squeezes the red clutch disc up against the flywheel. This engages the clutch and connects the transmission to the engine. The pressure plate spring can couple or clamp the clutch disc to the flywheel and pressure plate. Hydraulic or mechanical release mechanisms move the throwout bearing. This in turn applies or releases the pressure that couples and decouples the disc to the flywheel. Some clutch assemblies may even utilize twin discs to accommodate high torque applications while keeping the pedal effort to a minimum. There are two clutch release designs, the push release design and the pull release design. The purpose of the clutch is to separate the clutch disc from the pressure plate and the flywheel. Applying push force to the release bearing towards the crankshaft will activate the diaphragm spring and retract the pressure plate. Releasing the release bearing pressure will once again apply or engage the clutch. The pull release clutch moves the retraction clip inwards and the pivot location outwards. The diaphragm spring starts out concaved or dished in, and the release bearing is modified to handle the pull action instead of the push action. Pulling the release bearing away from the engine and the crankshaft will retract the pressure plate and release the clutch. Allowing the release bearing to return will apply or engage the clutch.